For our first example of probability, given the following information, we have 20 candies of total, 7 lemon, 8 pineapple, and 5 cherry. So there it says the probability of the first is cherry. So P of the first cherry equals 5 votes over 20, 5 cherry, and 20 candies total. So we can simplify it to 1/4, so that this is 25%. For the second one, B is that there is a probability of the second candy cherry given that the first cherry and was not returned. So P over the second cherry given that the first cherry wasn't returned, so P over the second cherry given that the first one was cherry equals to 4 over 19. One cherry candy because after doing that subtraction we have 4 over 19, which is the same as 21.08%. Then letter C says that the second candy is lemon given that the first cherry was cherry and was not returned. So P is the second lemon given that the first cherry was not returned. So that's 7 over 19 because we have 7 lemon and we subtract 1 to the total. So that's 7 over 19 equals 36.84%. For the next example, we are giving the following information. We have a die that is shown once. So we have to solve for the following. So letter A says that to get a 3. So equals P over 3 equals 1 over 6. Because we only have one die and they have six faces. And we have one chance over 6. Letter B says that we get a 2. And it's also 1 over 6. Letter C says that to get an even number. So P of even equals 3 over 6. Because we have 3 even numbers over 6 faces. So that is, which is to 1/2. Then letter D, they're asking to get a 3 and an even number. So P over 3 and the even number and is explained with this symbol. So P of 3 and even number equals 0 because 3 is not an even number. For letter E, they're asking us to get the probability of 2 and an even number. So equals of P2 and even number equals to 1 over 6. Next, on the F, we have to get 3 or an even number. So equals P over 3 or even number equals 1 over 6 plus 1 over 2, which is the same as 4 over 6 and can be simplified as 2 over 3. And finally, for letter G, to get a 2 or an even number. So equals P2 or an even number. So equals 1 over 6 plus 1 over 2 minus 1 over 6, which is the same as 1 over 2.
For explaining counting techniques, we're going to use the following examples. In the first one, we are told the information that we have 2 athletes which run 3 races, and we have to make the following. So we have the information that we have 2 athletes. We're going to name them A and B, and we have 3 races: race 1, race 2, and race 3. So we're going to draw this tree diagram. What this is telling us is that, for example, here A wins the first race, then the second race can be won by A or B, and the third race can be won by A or B, and if B wins the second race, it can be also won by A or B. This is the same panorama, but instead of A winning the first race, we have B winning the first race. So, using this diagram, we can easily solve the following problems. They are asking us the probability that any of the racers wins 2 races. So, we need to analyze the following schedule. The first one cannot be, because A wins the 3 races. So it's more than 2 races, so it doesn't fulfill. Here A wins 2, here A wins 2, and here B wins 2, so these 3 fulfill. On the second one, B loses the first race, but A wins second and third, so it is correct. Then B wins the first, loses the second, wins the third, so it is correct. The next one, B wins the first 2, but loses the third, so it fulfills. But the last one, B wins the 3 races, and the same as with A, it doesn't fulfill. So the probability of any winning 2 races is 6 over 8, which is the same as 3 over 4, which is the 70% of chance. Then, if they are asking us for the probability that A wins one or more races, we have P of A winning one or more races equals 7 over 8, because in the only outcome where A doesn't win any race is when B wins the 3 races, which is only 1. So it's 7 over 8, which is 87.5%. For our last example, they are telling us the following information. A test has 5 questions, with 4 possible answers. How many different ways of solving it there are? So, we need to make the following diagram. We have question 1, 2, 3, 4, and 5. And there are 4 possible answers for each question, A, B, C, and D. So question 1 has A, B, C, and D, which is 4. Question 2 has the same, A, B, C, and D, which is 4, and so on until question number 5. So, for solving it and getting the different ways of solving the quiz, we need to multiply all the possible answers times the number of questions. But it's not 4 times 5. We need to multiply 4 times 4 times 4 times 4 times 4. After making the multiplications, we end up with 1024 different ways of solving the exam.